Danner, you want to come intro this for me?
Sure.
Just real quick though. I want a slim down version. All right, well, so give me a quick rundown of this. This is a 2008 Ford Explorer. It came from another garage. This guy knows me from somewhere.
Well, he started talking about you and output state monitors, and he's like,
someone that's been paying attention, following along. You said he's a pretty sharp guy too.
Yeah, dude. Yeah, I mean, I felt his pain with, you know, because he said what it's doing is it's setting circuit codes, and the first one he was telling me was just the O2 heaters. But then as we start talking, it's the O2 heaters, the EGR, the EVAP Purge.
That would all share the same power feed.
Yeah, so he's like, I did not want to call a computer for this. He was like, but the computer's working. He was like, one of his tests was he pulled the plug off the O2 sensor and had another harness that he plugged into it and put a light bulb in the middle of it and turned the heater circuit
and it
on,
worked.
And it turned on, but it's
interesting.
Saying, but it's set in circuit codes.
I see all these circuit codes: O2 heater, heater circuit, EGR circuit.
Yeah.
EVAP, purge control valve.
And they all come off of fuse 42, he's saying.
Yeah.
You know, so he also bypassed fuse 42 and ran battery power to
just in case
a leg, just to make sure he didn't have a resistance issue. He said when he was under here, he did replace the engine harness. It's a plug and play unit, so the stuff on the EGR and the map, he said everything was deteriorated.
Okay.
You know what I mean? Like everything was, so he got a harness while he was at it. But originally, he didn't want to call the computer, but he did.
What was the original complaint?
The original was all these circuit codes.
So we're back to the, before he ever touched it, we're back to the original.
So he gets a computer. I don't know if an external guy programmed it or not. He takes it to Ford, because he don't know what to do at this point. It had
you said RAM codes.
RAM codes.
Yeah.
So they said, oh, it's programmed wrong. You know, so he paid Ford whatever their rate was to program the computer that he had bought, I think from Ford maybe, I don't know. On the way home it acted up again, so he took it back and they tried again, and then they ended up ordering another computer.
Wow.
Took 3 weeks or 4 weeks to get.
Oh my goodness.
They put it in, they programmed it, and now all these codes are back.
So the RAM codes are gone. It has a new PCM in it.
If it was just RAM, I would have told him no.
Yeah.
You know what I mean? I say go back to Ford, because I know you get frustrated and there's too many hands. Well, there would be too many pieces in the pie.
I agree. Appreciate that.
But then whenever he said, when I got the new computer and put it back in, he's like, I don't know if they gave me my old one back. Like, he's like, he don't know what to do. He needs a fresh set of eyes. You know what I mean?
Yeah. But we have circuit codes that shouldn't be there because we have voltage everywhere where we should, is what it sounds like.
And then if you do like the key on engine running test, I guess they come back immediately. Okay. Because it knows.
Yeah, I don't know. I'll do those things.
But that was the original complaint. He put a harness. I think he said he might have put a note in there of stuff he did. I don't know if you saw a note.
I didn't see the note. I didn't look though either.
But no, this guy is like where I hate being, where you hate being. You're like, I don't want to call the computer. You know what I mean? It's working. Why is it doing this?
Why do we have
like, I can make this stuff work.
And circuit fault codes are pretty straightforward. Like, if I would just attack, like, I'll probably do the EGR because it's right there.
Yeah.
Or the EVAP Purge because it's up top too. And then we'll just see where that leads me.
Yeah, Purge is right here.
Yeah.
You know what I mean? So that's that's where he's at, but he's like, I need a fresh set of eyes.
All right.
You know what I mean?
So I just cleared them, pending, no codes present, and then I'm just gonna start it. I'm not gonna do the run test. I'm just gonna start it. Or actually, I'll do the key on engine off test. Let's do that, self-test. That's just gonna exercise outputs, and it looks at voltage levels as it's turning them on and off. I hear things clicking. Completely normal. Yeah, immediate faults. AC compressor clutch relay, EVAP system purge, EGR fault. So all of those faults are there. Okay. Step one is pick something easy to get to. Use my incandescent test light. And I'm thinking purge valve, which is right here. And I'm gonna unplug it. I don't normally unplug it to do these kind of tests, but since we have multiple circuits, I'm not just worried about the purge. And then I'm just gonna back probe this with my test light. Lit on that wire, not lit on that wire. So the fact that that's lit I understand why this guy would be calling the computer and going the direction that he went. Because normally when you have like the EVAP Purge, EGR, O2s, AC compressor clutch relay, all of them, I'm assuming, sharing the same feed. When you have multiple codes like that, it's usually that you're missing a power feed. I am interested because I had this really weird Ford case study with a relocated fuse where I had voltage that was higher than battery voltage, and that's what I want to see. So my test light's not going to be my friend there. Just using the digital meter here, measuring battery voltage. I'm reading 11.9 on that. Then on my Purge wire, 1187. Okay, so nothing crazy. For reference, I have a case study on my premium channel. If you guys type in the search box, just type in 29 volts. Just type in 29 volts. And on this case study, it was a Ford Explorer that had a harness put in and had all this stuff very similar to what we're dealing with, that had a fuse that was relocated for the PCM in the wrong slot. And with the PCM also being the TCM, controlling the transmission control module, the transmission solenoids had power, and the PCM being half dead because there was another power feed that was there for the PCM, but the main one where you turn the key on was missing. And what that did is it caused the transmission solenoid, line pressure control solenoid, pulsing on and off to backfeed the voltage spikes from the collapsing field to backfeed the PCM circuit. And we actually read 29 volts on the PCM power wires that had no power. I know that makes zero sense. It should make zero sense. You should watch that case study, but that's what I was thinking about here. All right, so let's go back to the scanner. So those were immediate. And it starts and runs. Let me go to my service info real quick. Just pulling up the diagrams. Engine performance, 4-liter purge valve. Which wire am I on? The green wire. Okay, so the green wire also feeds the O2 sensors. EGR system comes up to mass airflow. So why would it feed? What is that? Why is there a solenoid there? That's kind of weird, the way that they have that drawn. It feeds the MAF. Fuse 42, that's the one that Danner had mentioned. Fuse 42 was the one that he was messing with, and then it goes to a deactivator switch on brake support pedal. Deactivator for what? Brake pressure switch. So it's just a BPS, brake pressure switch. Okay, so it's a pull up circuit, and the fact that we have voltage there and we're setting circuit codes is a huge concern. Let's look at this then during the test. Let's do that first. Plug this in, measure voltage. We'll clear these faults first. We're going to do the self-test while we're watching the meter. Let's change our time base to 2 seconds. We'll peak detect it, and then what we want, I want to watch the voltage level on this while we're doing the engine run. Oops. I selected engine running. I want key on, engine off. There's a big voltage spike there and a huge drop. Whoa. Danner.
Yo.
Want to see something cool?
I do.
Something I don't like.
Doesn't need a computer.
Nah, but I just did a split screen key on engine off test on that feed circuit.
Mm-hmm.
Look at those.
How was that?
Yeah, exactly. And then if you look at,
now that's supposed to be a straight up ground, right?
no, that's the feed. That's the power.
Oh, that's the feed.
That's the power feed to the solenoid. So this is the, right in this area, you know, this is before, like up in here is before I activated the key on engine off test. As soon as I hit key on engine off test, it did that first. Now you will get some spikes when solenoids are turned on and off, and there's a lot of things being turned on and off. But to see that low of voltage, look how low that is. That's like 6 volts. Let's see if let's show the min-max here.
If the computer's seeing a 6 volt,
it's gonna set a circuit code. I'm gonna do this test again and get more zoomed in on that, but I don't like that. All right, so let's hit run on this. Let's take our time base down to something that we can see a lot better. 500 milliseconds works. And then let's do the key on engine off self-test again. Yeah, big time drops.
that one?
So this is when I first turned it on.
Hey, I have another Explorer out there in the same vintage if you want to do it the same test.
Yeah, I mean we can, but I don't like this. I don't have a min-max scale on this particular scope I'm using, but that's dropping down to 6 volts. And so I understand why he ran a jumper wire.
I don't think he scoped it like you, but that's like part of the logic chain.
But he also, didn't he run a jumper wire to fit fuse 42, which feeds it?
I don't know if he went straight to the fuse or where he did it at. But he did run a 12 volt jumper wire to that circuit to bypass it. But if he went to that fuse and it's still got to go through the fuse box, maybe you have I don't know where the fuse is. Maybe, you know what I mean? If he went to the fuse, maybe it's before the fuse. You know what I mean? Maybe it's, you know what I mean? You know what I mean?
No, I'm in your head.
I mean, someone just got 3 shots right there.
You're allowed to say it, Danner. Yeah, I don't think that should be there. That's on the supply side of the circuit. You know? I want to watch let's see, what can I turn on that would draw the most amperage? And watch this circuit.
Probably the O2 heater circuit.
Well, I mean, look at that. That's just the initial surge of and I don't, the voltage spike higher, I don't really like either, but it's these low ones. Like that's about 6 volts right there. That's probably enough to set a circuit code. If I'd go in the computer and look, and that's why he also has bidirectional controls. Let's do that. Output controls. Canister vapor management valve, they call it. That'd be the guy I'm connected to. And let's run that, turn it on. I don't see any drop in voltage there at all. So I'm on the supply side, I can hear it. I'll switch it over to the control wire and you guys will see the drop. 12 volts with it off. It's ground side switch, chapter 3 material. Turn it on. That should have dropped. Why did it not? Because I might not be on the vapor management valve. Okay, so let's exit. Go into the math. Okay. To fill in the gaps, I apologize. I'm trying to talk through what I'm doing and teaching at the same time. Sometimes it's difficult. When we were on the purge valve and I was energizing what I thought was the purge called the vapor management valve, and I went on the control wire and I was looking for it to drop voltage. I said chapter 3 material. That did not function. I heard clicking, but it wasn't that valve, so that tells me that's not the vapor management valve, and I moved away from that. So that's really what I was doing there. I'm just shifting gears. I was only proving a concept there. I am concerned about low voltage on this circuit when things are being turned on, and I'm trying to prove it now. It's 26 after. 27 after. That clock.
You know what I mean?
Anyway, so I shifted gears real quick there on you guys because I believe we have a low voltage problem and I'm trying to prove it, and that's why I went to the EGR, the MAF, the EVAP vent or purge, things I can get to easily. And then what I want to do is load this circuit and see what it does. So let's redo on the MAF. Let's redo the key on engine off test. Huge spikes. I don't want to see this. I need to know what's making this voltage drop on this circuit. I'm gonna should snap on here for a minute. And I don't know if they fixed it in their next update. I'm on a 20.4 update. I'm using the scope viewer meter because I couldn't get the split screen that I want to do here within the lab scope itself. You have to go through the component test meter and then pick the meter tab and then minimize it. But here's the problem, Snap-on. You're gonna make me go that direction, but then you limit my scope usage from within here. In other words, in my scope right now, I cannot view my cursors and I cannot view min-max scales. So thanks a lot, Snap-on, for your insight in this function that I've been asking for 10 years. Give me a freaking meter tab that I can minimize my scope meter and go over so I can do active testing like I need to do on the scan tool and look at my meter at the same time. Instead, you make me go through hoops to pull up the meter and then you limit my meter function. That's a double whammy. Strike one, strike two. Apparently no strike three because I'm still using the damn tool. I'm irritated by that right now because I really want to measure the bottom of this spike. What's that dropping down to? The bottom of that one. Look at that one. That's got to be 6 volts right there. There's 6 way over here. That's got to be less than 6. I believe that is why I'm setting these codes, and it's a really important measurement, and I can't make it. Thank you. Thank you, Snap-on. Okay, so let's use a trigger then. If you're going to be that way, Snap-on, we'll get a little bit more creative. We'll go manual. And we'll do a falling edge. If you guys want more scope classes, look up my Picoscope Basics Part 1 and Part 2 on YouTube, and then I have a whole mess of scope stuff on my premium channel on my website. So I'm using a negative trigger. Gonna do the test again. That should draw that over that area. Let's go smaller time base. See if we can catch this.
Well, you're on the map?
Yeah, I wanted to catch this drop in voltage. Look, that's almost... Man.
What, it's showing up on that too? You're not even energizing.
Yeah, but the MAF is on the same circuit. So I'm on all of those circuits that are showing me that. Look at that drop.
Wow.
Look at that drop.
That's like below 6.
Yeah. That's where these codes are coming from. Something's causing a huge surge on that circuit.
Now, is it only one component doing that, or is it any time a component kicks?
I don't know, because I'm doing the key on engine off test, so it's going to be turning the O2 heaters on.
Yeah.
It's going to be turning the EGR on. It's going to be turning the purge valve on.
If you just did like purge valve by itself, would you see that, or an O2 by? Wouldn't that be funny if it was like a O2 pulling the circuit?
Well, I mean, we can maybe isolate it by unplugging things and then rerunning the key on engine off tests. You know, that's maybe a possibility, but the fact that voltage is dropping that low.
I'm just wondering, is that
here's the other?
Is that one showing up because it does it in sequence, though, right? Or is it doing it all at the same time?
Didn't you mention this had some kind of transmission going on?
Did I?
Originally, did this have some kind of transmission? No. Here's the other thing I don't like about this. I'm interpreting this as low voltage. It's really, on this one, it's a huge spike too. It may not be low voltage, that we have something spiking this circuit. Like, is the AC clutch on here like a clutch diode? Do you know what I mean? That's spiking it and then showing that negative voltage from the spike that's being misinterpreted as a circuit fault.
Usually if you read those circuit codes, it says if it's below 6 volt for a half a second or whatever. You know what I mean?
But like, look,
see, know what I mean? Damn it.
Hey, well, it's going to take some time, but we may have broken them and your drinking game's over.
It's over. I'll come up with a new one.
Drinking game's over. Let me do a longer time-based one again. I want to show you this again.
Now, my question, though, was when on the key on engine off test, is it doing them in sequence or is it hitting everything at once?
It does them in sequence, I think, Danner. 100 milliseconds this time. And then rerun the test. I have a trigger set for that. Okay, pause this. Zoom out. So, you know, the way that reacts, battery voltage there, something turns on, drops real low.
But even the voltage after that is low.
Right, because components are being turned on.
Yeah.
Components are being turned on. Each of these is more components being turned on. And that, in my opinion, is a final turn it off spike. The high part of it, up here. And then we're back to battery voltage. So
should that drop?
No.
That should be even. It shouldn't have those.
Yep, we shouldn't have that. fuse 42 that gets powered from the PCM power relay, as well as other fuses. Let's see if we see these same spikes at fuse 42. So this should be 15. It should be this circuit right here. Should be 42. Unfreeze this. This is the thing about manual trigger. See, there's no signal here right now. You got to be careful. You got to know your scopes. I need to make sure right now that I'm turning that off. So no trigger, and then you're going to see your line. So again, scope usage, this is really important stuff. But when I pull this fuse out, that should go away. It does. Okay. So I'm now interested in that circuit and the voltage level at that fuse to see if we're getting the same type of signal on the key on engine off self-test. This is at the fuse itself, and I believe that he said that he jumped it at the fuse. I don't see him there. It's after the fuse. Our problem is after the fuse. Those spikes should not be there.
Okay, so what does that mean?
We have a wiring harness problem from that fuse location to these components. And me jumping power to that fuse is not going to help us because my problem is not there. It's after the fuse. I was worried about looking at this, and I was worried about the main power relay, because the main power relay is going to latch and it's going to close and power that circuit. I'm no longer worried about the main power relay. It's a green wire in -2 engine harness near breakout. That's a splice, this S118 splice. I am interested in that. That is not where I expected that. S118's over there. Is this why he changed the harness? Is this the harness he changed? I mean, what the hell is it doing way over there? It could be this connector. I'm gonna pull this airbox up. I think it's under the airbox. That splice is supposed to be in here. Let's see if we see any cruddies. So it comes out right in front of a Y. So it should be right in here, because they show this Y right here would be this, I believe this Y right there, and it should be right in front. So it should be right in here, the S118 splice. And what I want to do, I want to monitor the voltage level on that circuit. That's going to be on the mass airflow. And then we could add a load to the purge line. Because if I'm looking for voltage drops, adding loads is important. How much did that drop when I added that? Not a significant amount. You got a headlight bulb, Danner. Like a 2-prong and some jumper wires, I could load this up. We do, huh?
I mean,
that works. That is some old school, but that's what
never
we need.
been opened.
You ain't ever going to use it either.
This is fit the Nova, man.
Oh, nice.
Except for I'm going to put LEDs in it. I mean, I have different bulbs if you don't want to use that thing.
No, it's fine. I just got to go get some jumper wires. I'll be right back.
All right, so give me a quick recap of what you're doing, because you get in a mode where you just do things and kind of say, not really.
I'm loading the circuit, and I'm going to wiggle shit over there.
Okay, why?
Because with the circuit loaded, then I'm going to see more of a voltage drop. And so I'm using a headlight bulb, and I'm tapping into the purge valve.
So you can visually see it?
So I can see it, so I can see it on, no, I don't care about the light.
Okay.
I'm going to use my scope as I'm doing this. When I connect this, light should light. Oh, huge voltage drop. Look, the voltage drop on my scope is ginormous whenever I connect this bulb. So we're going from 12, like initial drop. Yeah, that shouldn't be doing that. So I'm going from like 12 down to 10.
Ignoring spikes?
Yeah, I'm gonna get out of this scope now. because I need my min-max scales, and thanks Snap-on, I don't have it here, and so I gotta exit out of here. I have to close that off, hit my home tab, go to my scope multimeter, even though I was using the lab scope. And in here, now I have my min-max voltages that I can look at. And yeah, so 10, 9, and 11, 2. And when I connect and disconnect this, at least from this end, am I missing them? Might be. I'm on 20 milliseconds, so let's change that to 500. We are peak detected. Yeah, big time surges. Yeah, we're dropping down to 5 volts when I'm putting this light in. Yeah, it's like a 5 volt. And we went from the nominal voltage 11 volts, we're at 11.6, so a half a volt drop with this headlight in. And so with that in place, with a pretty decent load, I want to come over here and I just want to wiggle this connection here. Let me go a little bit longer time base.
You said something about a splice.
Well, the
or a
splice is
Y or
in here.
something?
Yeah, the splice is in here according to the diagram, but if we have damage in this area, I should be able to duplicate it. And I just didn't want to pull this apart if I didn't need to, and I was hoping that I could prove area, and it doesn't look like our problem is going to be in here, because if it was, I would be seeing some voltage fluctuations as I'm doing this, and I'm not. Let's see if we can see the splice though. Should be a bunch of green wires in here. So this is the one that goes from the fuse box to here, right? And then it continues on. So we just go to the next splice in the circuit. We could do the same measurements here though. This test will eliminate my need to pull the fuse box. This side should come from the box. And I'm gonna do the same key on engine off test. Let's take the bulb out just to get a good test here. I can leave that. Now we'll plug that back in. What I want to see is no drop here when I run this test. So key on engine off self-test is initiated. Back to my scope. No voltage drop at all. Oh, nope, it was there. That means then my problem is between here and the fuse box, because I'm seeing it here and I didn't see it at the fuse. One more time, let's do it at the fuse. Same check at the fuse. And this time we'll do both sides of the fuse. Just back probing the fuse. Scanner. Key on engine off self-test. Continue. Scope. Let's watch it. Yeah. Some slight voltage drops as things are being turned on and off, but we did not see those spikes. Go to the other side of the fuse, rerun the self-test, back to my scope. Not seeing those spikes. One little spike up after it was done. And that location should be directly from the fuse. Let's make sure that we're on the right circuit. I'm pretty sure we are because we saw those same spikes. So I have 12 volts there. If I unplug this fuse, that will go away, and it does. I believe if I run direct battery voltage into that line, we can make these codes go away. That's what I'm going to do. I do have a fuse here on this jumper wire. What I want to do, see, I don't want to mess up my probe because it's not meant for, those fingers aren't meant for high current, but this should be the source.
You just melted it.
I melted it and then I pulled it apart with my fingers. Jumping power here, just kind of a parallel branch of power, and then we can watch our circuit here, or we'll go back to the purge valve because that's where we were. So battery voltage jumped over to the splice, which should come directly from the fuse box. Parallel branch, I didn't interrupt the fuse box, I'm just adding to it. Step 1, let's run the key on engine off test while we are watching the scope. Nice. Oh, I got those spikes at the end though. Did not like that. Make sure that we're making good contact and don't have drops there. Let's plug the MAF back in so we don't have intake air temp and MAF codes. Clear them one more time. So it's cleared. Then we're going to run the key on engine off test while we're watching it. I didn't see the spikes at the beginning. I did see them at the end. And all of those came back. Could I be on the wrong side of the problem? Maybe I'm chasing a freaking ghost here. I just jumped directly to the purge valve. Forgetting the scope right now. Just want to see if these codes are coming back. Yeah, they're coming immediately back. I now understand, I really do, why this guy, whoever he is, that follows me too, appreciate that, thank you. I understand why you were running in circles on this one. I really do. See if that increased my voltage. So we're 12 volts. Just battery was getting weak. I'm just bringing battery voltage back up a bit with this charger on. I'm going to redo this self-test. Wait, am I not clearing those? Okay. The OBD codes, though, are not clearing. Or the key on engine off on demand codes. That's new. I'm a little bit lost now. Thought that test was going to work. I just want to know I'm chasing this right. You know, before I start pulling the harness apart, I should be able to make this code go away. It keeps coming back, and I'm running direct battery voltage at that leg. I've improved the noise in that. Let's check it at the MAF with my jumper installed. Run the test again.
Does that battery charger work?
Yeah, it's
All right.
so those spikes are still there. I can't get rid of them. I don't have the spikes at the fuse. I interpreted the wiring diagram as this is the first location. I found that splice. I went to that location and I have the spikes there, which said, hey, I got to go back to the fuse box. But if that's coming from there, I should be able to put direct battery voltage in there
Yes.
and fix it.
Yes.
but I can't. And I'm on the mass airflow right now with direct battery voltage there from the alternator, and I still have those spikes. So that's not fixing me jumping this into there is not fixing.
You're going just straight to the alternator feed.
Yes. I was using 2 jumper wires, but I'm like, well, maybe my wire's not, thick enough, and I'm not getting enough voltage in there. And with 2 wires, I have a drop, but I still have the spikes measuring on the MAF, and I'm like, I don't know which way to go with this. Like, and it's now like at the end. They shouldn't be there. I think that's what's causing these codes. Right? That just shouldn't be there, man. It shouldn't be there.
Do we know which component that is?
Well, no. I mean, it's going to be multiple components that are turning on and off. And this is at the very end of the test that we're getting that activity. But I don't know that that'd be enough. That just might be solenoids turning off, and that has nothing to do with it, and I'm barking up the wrong tree, and that's always going to be there. I don't know why I'm not seeing it at the fuse. I could start unplugging components. There might be something, whatever component that is, like you said. The problem in that is like, so it's heater stuff, EGR stuff, EVAP, purge control, AC compressor clutch relay. I wonder if I just pull some of these out one at a time and redo these tests.
Like I said, I have another vintage one of these out there if you want to just see if it's on that one, just because it's here.
I'm going to unplug the purge clutch relay. That should be the clutch relay. EGR. So monitoring the MAF, power wire still connected, purge valve unplugged, EGR unplugged, AC relay unplugged, redoing the test. Same spikes at the end. Extra codes. Feel like there's something else on this circuit that I'm unaware of. So I just pulled up a power distribution diagram, and I'm looking to see what else is on this fuse. So MAF, EGR, O2s, EVAP canister purge. I have that unplugged. Yeah, and that's it. So brake switch, purge, MAF, EGR, O2s. I don't really want to unplug all of the oxygen sensors. All right, I'm going to unplug this because I don't want to put the air cleaner back together. I'm going to run the car, leave the MAF unplugged, plug the EGR back in, leave that alone, plug the purge back in. Of course, my heater circuits are all off because I have codes for them. See if this will let me clear them. EGR circuit, EVAP purge, IAT, of course that one's going to be there. Clutch control, the heater circuits aren't there. The heaters are not turning on. They're all zeros, but it says they're on. Heater 1, heater 2. Heater 1, heater 2 says they're on, but I have no current flow on any of the heaters. But I have functional O2s, which means the heaters are working, but I don't see current flow. Where are these spikes coming from? I had a purge valve code with it running. I'm on the control wire this time of the purge valve. I'm gonna clear these faults. Yeah, the purge system, EVAP system purge control fault is there all the time. EGR circuit fault is there. Whoever you are, I understand. I'm gonna just pick one circuit. Stop going all over the place here. And I'm kind of maybe ignoring those spikes momentarily. I'm just not so sure about them. I want to go to this purge valve that's continuing to set a code all the time. I have a green and a brown yellow. Let's make sure we have a green and a brown yellow. Is that brown with a yellow? Is that purple yellow? That's it. All right. So we're gonna find our brown yellow wire at my ECM. We're just gonna attack this one circuit. Pin 6 on one of the ECM connectors. It's brown yellow next to a white with a blue. See what voltage we have there. That's the control wire of the purge valve. It is a ground side switch circuit. So with that showing me that kind of voltage, 13.5, the circuit's not being turned on right now. If it was, we'd have some pulses in there. It's ground side controlled. There's no reason that this circuit code should be there. Purge valve fault. It's there right away. I see why he called the ECM. I really do. I'm just gonna turn it off. Turn the key on. Clear these faults. Memory codes. This is with the key on, engine off. So no codes present under memory until I start it or run the self-test. The last thing I'm gonna do here today is check the ECM powers and grounds. Because we're setting codes we shouldn't be.
Yeah.
I am ignoring the spikes that we saw. I mean, maybe I shouldn't be. But I guess the reason I am is I'm monitoring the purge valve control right at the module. And I'm clearing the codes and I'm not seeing any voltage spikes or losses, and there's no problem there. There's nothing there. Like, it shouldn't be setting the code. Because I'm checking it at the module itself.
Yeah.
So that's making me move away from that problem as not a problem. Engine running or doing the self-test, the key on engine off self-test will make those codes come back. And right now, the memory codes right now is they're not there. And if I were to unplug the purge right now, it should show up. So I'm just reaching over, I'm unplugging the purge valve. It should, let's rerun the memory codes. It's not. That's weird. My mass airflow is unplugged. I should have memory codes for the MAF. For intake air and MAF's unplugged. That just adds more questions. Well, let's make sure I'm on the right circuit. That's still unplugged. 0 volts, which is what it should be. I measure it over there. So I plug this in, it should go to 12. And it does. I do have a battery charger on here, which is a little bit of the ripple in there. And if I do the self-test, there's your purge control. Computer's controlling it. You turn it off. This is a long time base, so that detail is not going to be great. So we're pulling down to about 2 volts. I would think that should pull lower than that. We could have a ground issue here. So let's just do a little experiment here. So this is a ground side switch solenoid. I mean, you really want to see these things pull lower than that. That's only pulling down to 2 volts. That's suggesting a possible grounding problem. Possible. Let's do the EGR. EGR valve regulator, violet white, it should be. Violet white should be my EGR valve control because it said EVR on the diagram. EVR is EGR valve regulator. All right, there's that. And then if I do the key on engine off test, should be pulsing this as well. Yeah, same thing. It's only pulling down to like 2 volts. Computer grounds are suspect. I'm just going to check these 4 grounds. So black, yellow wires. There's 4 of them on the ECM. These outer 4 right here. Let's key on. .01, that is good. 0.1, that is good. 0.01, no problem. All of those are good. Rerunning the key on engine run tests or off test while I'm monitoring it, just to load the circuit a little bit more. Nope, it looks good. All right, that is a wrap for today because Caleb and I just got our asses kicked by a different car that we fixed before we jumped into this one. And we're gonna step away and come back tomorrow, but you guys will be right here with us in the next segment, right? No.
When we start tomorrow.